Let's solve chapter 5 E1. A ball is traveling at a constant speed with 5 meters per second in a circle with a radius of 0.8 meter. What is the centripetal acceleration of the ball? So centripetal acceleration we can put as v square over r. So v is 5 meter per sec square divided by r as 0.8 meter. So you can have 25 divided by 0.8. Then you will get 31.25 meter per second square as your acceleration of centripetal acceleration. Okay, next question. As chapter 5 E2, a car is rounds a curve with the radius of 25 meter, which is r, and at the speed of 20 meter v. And what is the centripetal acceleration? So centripetal acceleration is v square over r. So 20 meter per sec square divided by 25 meter. So 20 square divided by 25, becoming 16 meter per second square as your 16, right? Okay, next question is chapter 5 E3. A ball traveling in a circle with a constant speed of 3 meters per second and the centripetal acceleration is 9 meters per second square. What is the radius? So AC equal v square over r. Then v know it, and then a know it, and then you need to find r. R equal v square over AC, which is v equals 3 meters per sec square divided by 9 meters per sec square. Then you will get 1 meter as your radius. Okay, the chapter 5 E4. How much larger is the required centripetal acceleration for a car rounding a curve at 60 miles per hour than for one rounding the same curve at 30 meters per hour, 30 miles per hour? Okay, so AC equal 30 mile per hour square divided by r, and AC 2, this is 1, right? And then 60 mile per hour square over r, then it's becoming 900 mile per hour square divided by r. This one's supposed to be 360 mile per hour square over r. So the difference between that could be 4 times. So 4 times the higher acceleration for 60 miles per hour. Okay, next question is E5. A 0.25 kilogram ball moving in circle with end of a string has a centripetal acceleration of 4 meters per second square. What is the magnitude of a centripetal force exerted string on the ball produced in acceleration? So FC equal MAC. So M equals 0.25 kilogram. Then AC equals 4 meters per second square, which is 1 Newton as your force. Okay, the next question is E6. A car with mass of 1200 kilogram is moving around the curve radius of 40 meters and a constant speed of 20 meters per second, about 45 miles per hour. What is the centripetal acceleration? So AC equal v square over r. V equal 20 meters per sec square divided by 40 meters. which is 10 meter per second square. Then, what is the magnitude of force required to produce centripetal acceleration? Fc equal MAC. M equal 1200 kilogram and A equal 10 meter per second square, which is 12,000 Newton as your force. Okay, the next question is E7. A car with mass of 1,000 kilogram travels around the curve with constant speed 27 meter, about 60 miles per hour. The radius of curvature is 40 meter. What is centripetal acceleration? Same as E6, right? AC equal V square over R, which is V is 27 meter per second and over 40 meter. Then 27 square divided by 40. Then 18.225 meter per second square. Then what is magnitude of horizontal component of the normal force that would be required to produce this centripetal acceleration in absence of any friction? In that case, also same, Fc equal MAC, which is M is 1,000 kilogram and AC is 18.225 meter per second square. Then 18.225 Newton is your centripetal force. Okay, next question, E8. Ferris wheel carnival has a radius of 12 meter and turns so that the speed of the rider is 8 meter per second. What is the magnitude of centripetal acceleration for the rider In that case, AC equal V square over R. V equal 8 meter per second square divided by 12 meter. Then 64 divided by 12. Then you will get 5.33 meter per second square. And then what is magnitude of net force required to produce centripetal acceleration for the rider? Of 70 kilogram. So Fc equal MAC, which is 70 kilogram times 5.33 meter per second square, then times 70, then 373.3 Newton. Okay. Okay. Now E9. What is the ratio of Earth's orbital period about the Sun to Earth's period of rotation its own axis? Okay. In order to make one period, one whole circle surrounding Sun by the Earth, and how many days in 1 year? 365.25. Okay, days equal 1 year, right? And how many days turn around the rotation by the rotation is 1 day. So the ratio is orbit period per the rotation period equal 365.25 days to 1 day. So that is your answer. Okay. Okay, the next question is E10 on chapter 5. Joe has weight of 720 Newton when he is standing on the surface of Earth. What would his weight, the gravitational force due to the Earth, be if doubled his distance from the center of the Earth by flying in spacecraft. Okay. Then this gravity is related with the distance, right? F of gravity is G m1 m2 over r square, right? Which is 720 Newton. Once this r is on the surface, then Fg2, which is on the air spacecraft, m2 over distance becoming 2r square, which means r square times g m1 m2 times 1/4. This portion becoming 720, then 1/4 of 720 Newton. So 720 divided by 4 becoming 180 Newton. Okay, that is your gravitational force once you have a double distance from the center of Earth. Okay, the next question is E11. Two masses are attracted by gravitational force of 0.36. Two masses, right? What will the force of attraction be if the distance between two masses are threefold? Okay, so Fg1 equal Gm1 m2 over r square, which is 0.36 Newton. Fg2 is threefold. It says this distance is threefold, which means Gm1 m2 over 3r square, right? Threefold. So in that case, Gm1 m2 over r square, then 1/9, 3 square 1/9, right? This portion is 0.36, then 1/9 times 0.36 Newton becoming 0.04 Newton in this case. Okay. Okay, the next question is E12. Two masses, two 100 kilogram masses are separated by a distance of 1 meter. And using Newton's law of gravitational force, and then find the magnitude of the gravitational force exerted by one mass on the other. Okay. Fg equal G m1 m2 over r square. G 6.67 times 10 to negative 11 Newton meter square per kilogram square times 200 kilogram and another 200 kilogram, right? 200 kilogram divided by the distance is 1 meter square, then 6.67 times 200 square becoming 2.66800. Yep, 266,800 times 10 to negative 11. So you move 1, 2, 3, 4. 4 moving, 5 moving, and then becoming 2.668 times 10 to negative 6 Newton, which is your gravitational force by 200 kilogram of two masses. Okay. Okay, the next question is E13. Two masses are attracted by gravitational force of 0.14 Newton. What will the force of attraction B, if the distance between these two masses in halves. In this case, Fg equal G m1 m2 over r square, which is 0.14 Newton. Fg2 is G m1 m2 over the distance becoming half, so r becoming half r square. Then G m1 m2 over r square, then 1 over 1 4, or the other way is 4 times G m1 m2 over r square. G m1 m2 r square, now you can replace with 0.14, then 0.14 Newton, then 4 times 0.14 becoming 0.56 Newton, which means 4 times, because the distance decreased in half. Okay, the next question is E14. The acceleration of gravity at the surface of Moon is approximately 1/6 of that at the surface of the Earth, 9.8 meter per second square. What is the weight on the astronaut standing on a Moon whose weight on Earth is 180 pounds? Okay, in this case, 1 pound equal as 4.45 Newton, right? Then 180 pound equal as 4.45 Newton over 1 pound. Then pound cancel out, then you will get 180 times 4.45. Then you will get 801 Newton, right? And that is your weight on Earth. Then your weight on Moon is 1/6 of 1/6 times the force of your weight of on Earth. Then 1/6 times 801 Newton becoming divided by 6, then you will get 133.5 Newton. That could convert with 1/6 of 180 Newton. Then could be 30 pounds or 133.5 Newton after convert as Newton. Okay, the next question is the E15. The acceleration of gravity on the surface of Jupiter is 26.7 meter per second square. What is the weight on Jupiter of the woman whose weight on Earth is 110 pounds? Okay, in this case, you can using 1 pound equal as 4.45 Newton, then 110 pounds equal times 4.45 Newton divided by 1 pound. Pound cancel, and then 110 times 4.45 becoming 489.5 Newton. This is Fg on Earth. Okay, then this force equal as mg, which is m times 9.8, right? 489.5 Newton equal as mg, then m times 9.8 meter per second square, this is all the magnitude we are dealing. So m becoming divided by 9.8, right, which is 99.95 kilogram as mass, and then Fg on Jupiter equal mg of Jupiter. Then m equal 49.95 kilogram. Then Jupiter gravity is 26.7 meter per second square. Then you just multiply 49.95 times 26.7 equal 1333.6 Newton as your gravitational force or weight on the Jupiter. Okay? Okay, the next question is E16. The time separating high tides is 12 hours 25 minutes, and high tide occur 2:10 p.m. one afternoon. And at what time will the high tide occur next afternoon? Okay, so period of tide is 12 hours 25 minutes. So it's up and down, up and down, up and down, up and down, so on, right? So this high tide and another high tide, another high tide. So from here is 2:10 p.m. The next one is 12 hours 25 minutes adding up. Then you will get 2:35 a.m. This is not next day afternoon yet, so another 12 hour 25 minutes. Then you adding up from the here, then 3 p.m. Okay, 3 p.m. is the next day high tide. Okay, and when you expect the low tide occur the next day. So low tide is supposed to be half of a period, which is 6 hours 12.5 minutes, right? You adding up, and then 8:22.5 p.m. and then from here you adding up 12 hours 25 minutes. Then this time supposed to be 47.5 a.m., which is in the next day morning. Okay, so that is your answer. Okay.